dear student, motion in a straight line, a moving train, a cricket ball hit by the bat, and a bird in a flight. They are the example for motion. Today we are discussing about the motion in a straight line. Here there are of two types. One is kinematics and another one is dynamics, which describe the motion of a particle. That is nothing but in order to define kinematics, the study of physics describing the motion. This is the branch which also describes the motion without a reference, without any reference to the cause of motion. Without any reference to the cause of motion, then that branch will be called as kinematics. Another one is dynamics, the study of motion. Relation to the cause of its motion is called dynamics. These two are the branches. One is kinematics, another one is dynamics. Next, the familiar physical quantity is position. What is position of the particle? So that is nothing but the location of the particle. Is nothing but is the location of the particle with respect to chosen point of reference. With respect to chosen point of reference, that one you can call it as opposition. Next is frame of reference. Frame of reference is nothing but system of coordinate axis, x axis, y axis, z axis. So there are three-dimensional space. In three-dimensional space, we are using three coordinates x, y, and z. Frame of reference is nothing but a system of coordinate axis which defines the position of the particle or an event in a two or three-dimensional space. So, which frame of reference is a coordinate axis which defines the position of the particle, or an event in two-dimensional or three-dimensional space. This is about frame of reference. Distance and displacement. These two are the different physical quantities. Distance is defined as distance traveled by the particle is the length of the actual path traversed by the particle during the motion in the given interval of time. So it is nothing but the length of the actual path traveled by the particle in a given interval of time is called distance. Distance is a scalar quantity, and the third one result is distance is always positive. In case of displacement, this is also another physical quantity. It is defined as the change in the position of the particle in a particular direction. And is given by the vector joining the initial position and the final position. Displacement is a vector quantity. It has a magnitude as well as direction. Because of that, displacement is a vector quantity. Displacement may be positive, a negative, or zero. But in case of distance, it is always positive, and this one is a scalar. Next is position time graph. Position time graph, or you can call as PT graph. PT graph is a graph of position of a particle as a function of time is called position time graph. You have to take position x along y axis and time along x axis. So the graph of position and time is called PT graph. So PT graph for different cases. So this is a graph of position and time. This graph represents the straight line, represents the object is at rest. For second graph, this is a graph between x axis, position is taken along y axis and time is along x axis. other than origin. This is